Good morning, friends. My name is Nikhil Doy. I'm finally an undergrad in IIT Tirupati. This is a small introduction to Pneumothorax Segmentation Challenge. So let's begin. Uh, Imagine suddenly gasping for air, helplessly breathless for no apparent reason. What could it be? Could it be a collapsed lung? Well, we will be able to predict that after solving this grand challenge. In this grand challenge, we are expected to develop a model to classify and, if present, segment pneumothorax from a set of chest radiographic images. The above condition is known as pneumothorax. Pneumothorax occurs when air leaks into the space between your lung and chest wall. This air pushes on the outside of your lung and makes it collapse. Symptoms typically include one-sided chest pain and shortness of breath. This grand challenge has been proposed by Society for Imaging Informatics in Medicine. Their mission is to advance medical imaging informatics across the enterprise through education, research, and innovation in a multidisciplinary community. Now let's see the data set provided by them. They have provided 3,205 TCMR files, which are X-ray images, uh, in which around 1,000 are in which 1,000 contains pneumothorax. The image size is 25 to 255 cross 128. So then these images have been coupled are provided in a format of DCIOM. DCIOM is a format that has metadata as well as pixel data attached to it. You will know about the gender and the age of the patient as well as info about the image that is sampled and generated. The rest, the segmented masks have been provided to us. That data is comprised of images in DICOM format and annotations in the form of image IDs and RLE mask. Run length encoding is a form of lossless data compression technique. Modality used um, in this modality used in this challenge is radiography. The X-ray images have been provided, so it's clearly radiography. If you can see, this blue arrow indicates the pneumothorax. So let's look at the leaderboard and look at the solution of Mr. Anwar Imoldin. Uh, I will try to explain the algorithm in as simple as possible. Okay. So first of all, he collected the input data so the input data needs pre-processing. So he did aggressive augmentation. Usually aggressive augmentation is not preferred, but since he is getting a good accuracy, so he is using aggressive augmentation. Next, it is an imbalanced data set. To tackle that, he has used sliding samples. Uh, Next is process data goes to in our model. Our model consists of it's actually model zoo, so he uses three different models: ResNet 34, ResNet 50, and Cerex Next 50. Then this model has a loss function. This loss function is a combination of binary cross entropy, dice loss, and focal loss, which have been provided with suitable weights. Next, uh, next this image after training the model, this after training the model, the output has been post-processed using the triplet rule. This triplet rule is used to approximate the values in the final layer of CNN. Next, and then this model makes the prediction. He has used the best checkpoints from each experiment. Uh, one more thing to add, leader has specifically reduced learning rate over time and has reduced sample rate too. Mm, yeah, so yeah. Finally, I would like to thank you all for your time. These are the references. This is the Kaggle competition, and the video and this YouTube link will get you to the solution provided by the leaderboard winner. Leaderboard. Yeah. Thank you.